weather lecture, which is going to be our segue into our severe weather, which I know you guys are looking forward to. So, what is weather? It's the atmospheric conditions along with short-term changes of a certain place at a certain time. Again, we know that weather can change very rapidly. Climate is a temperature and weather that are present in an area over a long period of time. So, weather variables play a huge role in the type of weather that we have. And these variables are used by meteorologists to describe all the different atmospheric conditions that we could have. So, air temperature is the measure of the average kinetic energy of molecules in the air. Kinetic energy is just movement. So, for instance, if you are riding a roller coaster and you're at the very, very top of the hill, you have what's called potential energy. And as soon as you guys go down that hill, you now have kinetic energy. So it's all the movement. So air temperature is really measuring the average movement of the molecules in the air. Air pressure is the pressure that a column of air exerts on the air or a surface below it. So air pressure decreases as altitude increases. That means that the farther we go up, the thinner the air gets. There's less air pressure. So that is one reason why you may find it harder to breathe if you were to go on vacation, let's say in Colorado, and go skiing in the mountains. Wind is created when air moves from an area of high pressure to an area of low pressure. Humidity is the amount of water vapor in the air. So we've been hearing a lot about water vapor, and here in Florida we have a lot of humidity because we have a lot of water vapor. We're surrounded by pretty much water everywhere except for our northern border, so we are a peninsula. And high humidity means we have a high water vapor, which means that there's a sticky feeling because sweat doesn't evaporate well. So especially after the hurricane, when we all had no power, I'm sure when you walked out of, you just woke up in bed and you were sweating, you took a shower, walked back out, you're sweating again, it was almost like pointless. You get that sticky feeling because of the fact that there's high humidity. Relative humidity, which is what you might hear about a lot on the news, is the amount of water vapor present in the air compared to the maximum amount of water vapor the air could contain at that temperature. So what that means is that if the air temperature is 60 degrees, there's only supposed to be so much water vapor for that temperature. So relative humidity is what amount of humidity is there versus the maximum that could be there for that temperature. So you'll see that normally in a percentage. And then dew point is the temperature at which air is fully saturated. That means it's full of water because of decreasing temperatures while holding the amount of moisture constant. So sometimes you'll see on the news about dew point, and that's where this slide comes in. So what do they mean? Dew point versus relative humidity. Well, dew point is how much water vapor is in the air, the absolute measure. So if your dew point is greater than 60 degrees, it's going to feel really uncomfortable. If your dew point is less than 60 degrees, it's going to feel more comfortable. Where relative humidity is, again, how much water vapor is in the air out of what is allowed for, let's say, that 60 degrees. So if you have less than 40%, it's going to feel dry out. And if you have more than 80%, it's going to definitely feel wet out. It's going to feel moist. That's normally when you're listening to the meteorologist and they tell you, oh, well, it's 80 degrees, but relative humidity is 70%. So it really feels like 95. That's where that comes into play. And then pressure systems. Pressure systems, you hear about a lot on the news when you're watching the weather. And weather is really influenced a lot by pressure systems. Hurricane Irma was influenced a lot by a pressure system. So cool air molecules are closer together, so they have higher pressure than warm air. So what that means is that they're not moving as much because it's colder. So the molecules stick closer together, so there is higher pressure. When you have warmer air is going to be spread out more because they're constantly moving. All the molecules are moving really fast and they're spread out. So it's less pressure because they're all spread out. Cold air has more of them closer together. Hot air has them more spread out. So that's why cold air will have the higher pressure and warmer air will have lower pressure. So a high pressure system is a large body of circulating air with high pressure at its center and the low pressure towards the outside. And those days will bring sunny skies and fair weather. So those are happy days because those are days we can go outside and play, go to the beach, stuff like that. So high pressure equals happy weather. A low pressure system is a large body of circulating air with low pressure at the center and high pressure towards the outside. And that brings us with cloudy days and plenty of precipitation. So lousy weather, the times that we can't do anything outside and you guys get really bored. So low pressure, lousy weather. That's how be an easier way of remembering those things. And in this image, you can see the difference here. On the left-hand side, that is a high pressure system. So the high pressure is in the center. So it's pushing down because, again, cold air sinks and hot air rises. So you can see the cold air is sinking towards this, is in the center and it's sinking and then spreading out where the lower pressure is. And that lower pressure, it'll rise. And we have a good sunny day. Where on the right hand side, we have a low pressure system. So hot air is going to rise up. And when that hot air rises up towards the center, that water vapor is going to cool as it goes up and it's going to form clouds because that's the process of condensation. And when those clouds end up getting too full and the water droplets become too large, we have precipitation. So it makes sense that it has the lousy weather that is associated with it. And here's another example of how you would be seeing high pressure and low pressure systems. And then as you can see, there's that jet stream in there in the middle. And Hurricane Irma's track was very much influenced with these three components. The jet stream at the time was what we knew was going to cause Irma to do that almost 90-degree turn. But in the beginning, we thought Miami was going to get hit dead on, and that was just because we didn't know if the high pressure system on that side of the jet stream was going to move in time to push her farther to the west. And as it got closer and closer to D-Day, the time when she was coming to make landfall, that pressure system did come in and was able to influence and move her out of the way. So it moved her out of a direct hit for us. I mean, we still got hit, but we didn't get the direct hit. We didn't get the eye of the storm like the west coast of Florida did. So that's how those things affect something as major as a hurricane. The next thing we're going to talk about is air masses. Air masses are large bodies of air large bodies of air. That's what it's supposed to say. That's a typo there. That have uniform temperature, humidity, and pressure, and they form when a large high pressure system lingers over an area for several days. So as a high pressure system comes in contact with the Earth, the air in that system takes on the temperature and moisture characteristics of the surface below it. So it's going to be different depending on where it is stationed around the world. So we have different types. We have an Arctic air mass, which will form over Siberia and the Arctic, so it's extremely cold, dry air, and the temperatures can drop to negative 40 degrees Fahrenheit. It's extremely cold. Nobody wants to be out in that kind of weather. You get frostbite in that type of weather. You have a continental polar air mass, which is fast moving and it brings in cold temperatures in the wintertime and cooler weather in the summer, and that's normally located over Canada. We have maritime polar air masses, which form over the northern Atlantic and Pacific Oceans. So anytime you see maritime, it's going to be over the ocean. And they're cold and humid, and they often bring cloudy and rainy weather. So if you've ever watched Twilight, that explains, why it's constantly raining in the movie, because it's set in Portland or in that area, in Washington and Oregon and stuff like that. We have that continental tropical air mass, which forms over the tropics, and they are hot and dry, and they bring in clear skies and high temperatures, and usually form over the summer. And then we have the maritime tropical air masses, which form over the western Atlantic, the Gulf of Mexico, and the eastern Pacific Ocean. And they bring in hot, humid air to Florida and the southeast United States during the summer. And in winter, they would bring heavy snowfall. Obviously, not in Florida, we're a little too far south, but in places like North and South Carolina, Georgia, Tennessee, Alabama, areas like that. Now, this is a great image to show you where all these air masses are located and in which direction those air masses affect. so you can see all of the different ones in their geographical location. Fronts is the next thing. We hear about fronts all the time on the news. They tell you you're having a cold front, we're having a warm front. So this is where we're going to talk about those. And a weather front is a boundary between two air masses. So two air masses are meeting, that cold front is that boundary, or that warm front is that boundary. So a cold front is when a cold air mass meets up with a warm air mass, and the warm air will rise and the water vapor cools, and you get showers and thunderstorms that often form along cold fronts and often give rise to severe thunderstorms. That's one reason why when you hear on the news that we're having a cold front, you know that it's probably going to be a wet weekend or a wet week depending on when we're getting the cold front. There's always normally some rain, because remember, warm air will always rise, cold air will always sink. So that when that warm air rises, that water vapor ends up cooling, and there's that condensation, and then the condensation leads to the precipitation. So the cold air is always going to go underneath that warm air. And then with a warm front is when the warm air mass will meet the cold air mass, and again the warm air will rise, but it'll glide over, and it'll create a wide blanket of clouds. So here it's more of like a cloudy day, and it often does bring steady rain or snow for several hours. It causes the wind to shift directions as well. So again, the warm air has to go up higher, so it's the water vapor is cooling, creating the precipitation, except it's there for a few hours. It's not like a quick rainstorm, or a quick thunderstorm. We also have a stationary front, and that's when the two different air masses stall. They literally meet up with each other, and neither one of them wants to move. So we have cloudy skies and light rain, and they're normally found along those stationary fronts. A cold front that moves faster than a warm front will sometimes block it, and it's called an occluded front, and that usually brings lots of precipitation as well. So these are the images that you would see on a news forecast or on a weather map if you were to look it up. And this is an image of what it would be, where you can see the different types. So it shows you the direction of the front and what happens when each air mass meets the other one. So that's the end of the weather section, and now we can get on to the fun stuff, the severe weather.